right, so let's take a look at our assignment here. So these were probably the hardest ones from yesterday. So we're finding f of g of x. So let's take our g of x and replace it here. So this is really f of 1 over x. Okay, so now we're going to go to our f function. So go to our f and we're going to replace that x with 1 over x. So 1 over x plus 2. And now we need to find the domain. So the domain, we check our input of 1 over x, and we check our final of 1 over x plus 2 for restrictions. Well, there's a fraction, so we can't divide by 0. So our restrictions, well, it can be all real numbers, but x cannot be 0. So let's try going the other way here. So the second one says find g of f of x. So now I'm going to take my f of x right here and substitute it in. So this is g of x plus 2. So now I go to my g function up there, and I replace the x with x plus 2. So there's our equation right here, our answer. And again, for the domains, we check our input of x plus 2, which doesn't have any restrictions, and our final of 1 over x plus 2. Well, again, the denominator cannot equal 0. So if we solve that, x cannot equal negative 2. So it's all real numbers except x can't be negative 2. Okay, so our next one, it says f of g of x. So here's our g of x. So this is really f of x squared. So I go to f and I replace that x with the square root of 4 minus x squared. And then our domain restrictions. So we check our input of x squared, which there's no restrictions, and the final one, so the square root of 4 minus x squared. Well, underneath a square root, it has to be greater than 0. So minus 4 minus 4. So negative x squared is greater than or equal to negative 4. Divide by negative 1. So we have x squared is greater than or equal to 4. But when we divide by a negative, I almost forgot, we have to switch this sign. And then we square root. So x is less than or equal to 2. But what would that work for the negative numbers? If it's less than or equal to 2, that's like 1 and 2. So that means negative 1 and 2 would work as well, because negative 1 squared is 1, which is less than 4. Negative 2 squared, that's less than 4. And negative 2 squared is also less than or equal to 4. So we'd say x is greater than or equal to negative 2. So if we use this notation, it's in between negative 2 and 2. Where did that next page go? I seem to be missing a page. Let's see. Let me see if I can find it here. Did I accidentally delete a page? Sorry guys, let me quick grab that again because somehow we are missing a page here. So let's see. See my messy desktop, so we need 2.7 part B. There we go. All right, so here's that page. Okay, so now we're doing g of f of x. So again, here's our f of x. So this is really g of the square root of 4 minus x. So I go to my g function and I replace the x with the square root of 4 minus x squared. Well, square root and squared, so this is just 4 minus x. All right, so let's check our input. The square root of 4 minus x. And our final of 4 minus x. Well, there's no restriction on our final, but on our input, 4 minus x, since it's underneath a square root, has to be greater than 0. So negative x is greater than or equal to negative 4. divide by -1, we flip the inequality, so x has to be less than or equal to 4. All right, so we have f of g of x. Okay, so we have f of 3 over x squared. So I go to my f function. So this becomes 3 over x squared. Oh, excuse me, I wrote this wrong. Sorry, that is 1 over x squared. And how we divide fractions, we keep our numerator times the reciprocal. So this is just really 3x squared. So the domain, we have our input, 1 over x squared, and we have our final of 3x squared. Well, there's no restrictions on 3x squared. So on our input, the denominator cannot equal 0. So x can't be 0. So it's all real numbers except x can't be 0. All right, and then we have g of f of x. So I'm going to take this f of x function. So this is really g of 3 over x squared equals, okay, so I'm going to go to the g function and replace the x. So 1 over 3 divided by x squared. So the numerator times the reciprocal. So that is just x squared over 3. All right, well, let's check our input for domain restrictions. 3 over x squared. Our final is x squared over 3, no domain restrictions. But once again, our denominator cannot equal 0. So x squared cannot equal 0. So x can't be 0. So it's all real numbers except x cannot be 0. And then these final ones are a little easier. We're identifying our inside and outside functions. Well, this has something to the 4th power. So that's our outside. And what did we input into that x? Would be the 2x minus 7. Well, number 14 has a fraction. So that would be our outside. And what did we put in the denominator? Would be x plus 3. This one has an e, but it's really similar. So there's something in our exponent, so the outside is e to the x. The inside would be x cubed. And the square roots are easy. So we had a square root function, and underneath we inputted x squared minus x. Now this last one is a little bit trickier. So given that f of x equals cx minus 3 and g of x is cx plus 5 are both defined on a set of all real numbers and c is constant, what is the value of f of g of x? It equals g of f of x for all real numbers. Okay, so this is really f of our g of x, so cx plus 5, equals g of our f of x, cx minus 3. There's a lot of letters on this. Okay, so I go to my f function, which is right here. So I replace the x with cx plus 5 minus 3 equals, I go to my g function, so c, but I replace the x with cx minus 3 plus 5. So if I distribute here, I got c squared times x plus 5c minus 3. Over here, c squared minus 3c, there's an x there, plus 5. Well, those are the same on each side. So now I'm just solving the equation. So let's see, add 3c. Sorry, this should have been a c when I distributed, my bad. Plus 3c. So we have 8c minus 3 equals 5. Plus 3 plus 3. 8c equals 8, so c equals 1. And then this last one, there's a linear piecewise defined on -3 to 3 is shown in the graph. The function is given by x minus 2. So this is really f of x minus 2. So I just move it to the right 2. So right 2, right 1, 2, 1, 2, 1, 2. And we have our graph.